Hi there, I'm Ryan, a maintainer of mlpack. In this tutorial video, I'm going to demonstrate how to install mlpack C++ headers on a variety of operating systems. This is the setup that's needed to compile C++ programs that use mlpack. If you're interested in mlpack's bindings to other languages, such as Python, see the other videos in the documentation on mlpack's website. And if you're interested in contributing to mlpack and developing the library directly, see the video on setting up an mlpack development environment. So, in this video, I'll be covering these setups: Ubuntu and Debian, Fedora and Red Hat, macOS using Homebrew, installing mlpack from source, and installing mlpack from source using the auto downloader to get dependencies. Okay, let's dig in. Okay, so first let's talk about getting mlpack set up on an Ubuntu system. Now these instructions will also work for Debian and other systems that use the apt package manager. The setup is actually quite simple. I can just depend on the apt package manager to do all of the work for us. So I'll type sudo apt-get install libmlpack dev. That will install the headers of the mlpack library for us, which is all that we need. And then we also need a C++ compiler. So if you don't already have one installed on your system, you can add, say, G++ to this list. So this command will install a bunch of packages. It installs not only mlpack, but also its dependencies, and it also installs the compiler and all of the compiler's dependencies. So when this command is done, we'll have a fully working system in which we can write mlpack programs and compile them without any issues. But it takes just a second. So now that that's done, we can go ahead and write a very simple program to show that things work. So I'm going to open a file called test.cpp, and this is going to be not exactly the most complicated machine learning program you could ever think. All I'm going to do is just print the version of mlpack. mlpack util get version. That returns the version of mlpack as a string. Okay, so save and write the file. I'll just cat the file so we can see it on the screen. There's our program that we want to compile. And the way that we'll compile it is just with a simple called G++. -O specifies the name of the program we want to compile. So it'll be saved in this test. Test will be the name of the program we write. Test.cpp is the source file we want to compile, and then -L armadillo indicates that we need to link against the armadillo library. So any mlpack program needs to link against armadillo, but the headers are already available, so we don't need to do anything else. Now that this is done, we have a file called test. It is a program. When we run it, it prints the version of mlpack. And now I want to point out that this version of mlpack is not the newest version of mlpack. The versions that are packaged by Ubuntu and Debian are generally a little bit behind the latest version. So if you do want the latest version, you would want to install from source. Okay, so next let's talk about installing mlpack on Fedora and Red Hat Linux systems. So here, the instructions will actually be very similar to what we do for Ubuntu. We can just depend on the package manager. But in Fedora, the package manager is called DNF. So all we need to do is sudo DNF install mlpack-devel. And this system is clean. It has nothing installed on it. So I also need to install a compiler. And again, I'll just install G++. So this will install a bunch of packages, and it takes a little while to install them. But this installs not just mlpack, but also all of the dependencies of mlpack, so we don't need to worry about those, as well as the compiler. So now that this is done, we can write a simple test program, which I will do here. And this test program is not going to be very exciting. Let's put it like that. And all I'm going to do is print the version of mlpack. Again, not exactly rocket science, but in the end we have a fairly simple program that if we compile this, any mlpack program we can compile in this way. We'll just call G++-O test, test.cpp, and then we need to link against armadillo. And so that'll take a second or two to compile. But when it does, we'll have a program called test in this directory that we can run, and it prints the version of mlpack. So now the version of mlpack that's available in the Fedora and Red Hat repositories, especially in the Red Hat ones, is often out of date. So this is version 4.4, but the newest version is 4.5. So if you want to use mlpack with the newest version, then you will want to go ahead and download and install from source. Okay, next let's look at installing mlpack on OS X. So here I'm going to assume that you already have a system that has a C++ compiler installed. So here I've done it through the Xcode command line tools, so you can go and install those through Apple's process, and then you have a C++ compiler. I'm also going to assume that you're using Homebrew. So once you have Homebrew set up, really all you need to do is brew install mlpack, and this will go and download mlpack, and it might take a second or two. Okay, and when this is all done, like I said, it could take a minute. Now you have mlpack set up, and so we can write a simple test program. So the test program I've been using for the other installations, we'll do the same thing here. That's really simple. Just print the version of mlpack. mlpack util get version. Cool. And now that that's done, we can compile. But so as I mentioned, I'm using the Xcode compiler. There are a couple of extra things that we have to do here. First, I need to specify the C++ standard as C++ 17. Otherwise, we will get compilation failures because it'll be in too old of a mode. I'll specify that I want test to be the program we build. Test.cpp is the file I was just working on. But now I need to do something else. I need to tell the compiler where all of the headers installed through Homebrew are. So my installation is in /op/homebrew. So I'll specify the include files with the -I option. Then I also need to specify where the libraries are found. That's in opt homebrew lib for me. And then we can link against Armadillo. So now the Xcode compiler will look into the Homebrew installed libraries and compile the program. And once that's compiled, we can then run it, and we can see, oh, look, there's the version of mlpack. The version of mlpack in Homebrew is not always the newest available version, and it assumes that you're using Homebrew. If that's not the case, or if you want a new version, it's probably better to compile from source. Now let's talk about building mlpack from source. Here I'm going to do that on an Ubuntu system, but the directions would be the same for OS X or Fedora or anything else. The things that you need before we start this is you need to have a compiler installed. So here I've just got GCC and G++ installed, and you need CMake to actually configure and perform the build. Here we'll use the package managers to get the dependencies of mlpack. In our case, there are 4 dependencies of mlpack. The first is Armadillo, a linear algebra library. The second is Insmolin, a numerical optimization library. The third is Serial, a serialization library, so you can save and load mlpack models from disk. And the fourth is libstb, which is a set of image processing utilities. So once these packages are installed on the system, we should have everything we need to configure and install mlpack. So I'm going to go ahead and get the latest version of mlpack directly from their website with wget, but you could download it in your web browser, be that Firefox or whatever. There are lots of ways to get it, but once you have whatever version of mlpack you're looking for, you can go ahead and unpack it. And once it's unpacked, you can see the version that we've got. The latest version is mlpack 4.5.0. This has the entire release in it. Building with CMake, the first step is to make a build directory. This will have everything associated with the build. And then the second step is to use CMake to configure the library. Now, in the simplest case, we could just type this. But I want to specify a couple. We have the option of specifying a handful of options, so I'm going to. You could run this as is, but I'm going to specify a couple of things here. The first one is this option build CLI executable. So by default, mlpack has a number of command line programs, but here we're only interested in using mlpack from C++. So I'm actually going to set this to off. Second, I'm going to specify, this is already the default, but I want to point out that this option exists. I'm going to specify that we don't want to build tests. So those are the two options that I want to give. There are lots more options detailed in the documentation where we could specify where our dependencies are, but CMake should be able to find all of those. So when I go ahead and run it, everything gets configured, and then I can just type make. And I can type make-j8, which will use 8 cores. But there's really nothing to build here because we're not compiling the command line programs. So with everything built, and again, there's nothing to build here, then I can type sudo make install. And this will install all of the mlpack headers to, as you can see, user local include. And so now I could write a simple test program. And this is the test program I've been using throughout this whole video. That just prints the version of mlpack. Mlpack version. Mlpack util get version. And we can compile this just from the command line, just like this. And everything's already on the search path and everything like that, because mlpack is installed to user local include, and we can run the program, and it works. Now, I also want to point out that we have the option of not installing mlpack and using it directly in the directory that it was unpacked to. So to demonstrate that, I'm going to just go ahead and remove everything that we just installed. That's all the headers. So now the headers aren't available, and my compilation command would fail because mlpack is not found. I can specify to GCC that it should search directly where I unpacked mlpack in the source directory for the mlpack headers. And so now it finds the headers again, and these are the local headers that aren't installed. And in fact, you don't even need to run CMake if you want to do it like this, and the program will still work. Okay, lastly, I want to talk about installing mlpack from source using mlpack's auto downloader to download the dependencies of mlpack. So here I'm doing this on an Ubuntu system, but you can really use any system for this. My only assumptions are that CMake is available, a C++ compiler is available, and a version of BLOS is installed, so like OpenBLOS. So if you have any scientific computing on your system, it's probably already available. So the first step, now that we have those available, is to go ahead and download the latest version of mlpack. So I've just done it directly here with wget, but you could use Firefox or by going directly to the mlpack website or whatever means you want to get this file. So when I unpack it, the latest version of mlpack is 4.5.0. I can go into that directory and it has all of my sources. To build with CMake, we need to make a separate build directory, which I'm going to do, and then change into that directory. And then I am going to configure the library with a CMake call. And in this case, I want to specify that I should use the auto downloader. And so this option is specified with the -d download dependencies equals on flag. So when CMake doesn't find Armadillo or Insmolin or whatever, it will go and get it. The other flag that I want to specify, which is just for the purposes of this tutorial, is -d build CLI executables equals off. So mlpack comes with a number of command line programs that do various machine learning tasks, but in this tutorial, I'm only demonstrating how you can compile C++ programs. So you don't need the pre-compiled command line programs. You just need the C++ library. So when I run CMake, it goes and it downloads those dependencies that I don't have on the system. Then I build the library. There's nothing to build because we're not building the command line program, so that's very fast. And then I can go ahead and install everything with sudo make install. And so that installs not only mlpack, but also all the dependencies of mlpack to the install directory. So you can see I now have Armadillo, I have Serial, I have Insmolin, and I have mlpack and stb. So that's all the dependencies that the auto downloader downloaded. They're all now available on the system. So if I want to write a simple C++ program that uses mlpack, like this trusty one that I've been writing over and over again during this video, where I just print the version of mlpack, When I compile that, I don't actually need to specify any extra directories. Everything is already there. Now, one note is that because the auto downloader installs Armadillo in header only mode, instead of the -L Armadillo I've been doing earlier, we want -L OpenBLOS or -L whatever BLOS it is that you have installed. And so that's used by Armadillo for linear algebra operations. Once that compilation is done, I can then run the program, and hey, look, we have mlpack 4.5.0 installed and ready to go. All right, so just to wrap up, hopefully this tutorial was useful to you. Although we only talked about a couple of setups, the basic idea is the same in all cases. One, you can use a package manager to install the mlpack headers, and then you can compile programs that use mlpack. Or two, you can download the source and unpack it manually, and either use the mlpack library directly in place without installation, where you'll need to also specify the include directory directly to the compiler, or you can use CMake to install the headers system-wide. So this video was quite introductory, but in all cases, much more detailed documentation, including build documentation and usage documentation, is available on the mlpack website. So mlpack does do more than just print the version, of course. And if you have any issues or you find any problems, don't hesitate to post an issue on GitHub. Thanks for watching.